I'm going to teach you about mass defect and nuclear binding energy. I'm going to start with mass defect, and this is the phenomenon where the put together atoms actually weigh less than the individual pairs that make up the atom. This is what you would say is the put together atom. And up here you have the atomic mass, right here is the atomic number, and right here is the mass of this whole thing. When given a problem with mass defect, you will be given a chart with protons, neutron, and electrons. Each of these individually have a mass, and what you would do is you would multiply each of these masses, the masses of each particle, with the number of protons, neutrons, and electrons that is in your atom. Now what you're going to do is you're going to multiply the number of protons, neutrons, and electrons by the mass of the particles, which is given up here, these three, in order to get the mass of copper-63, which is our atom. So once you figure that all out, you add them all together, and this is what the mass of copper-63 is from each particles added up. And now I'm just comparing the two to prove to you that, to prove my statement that I said before, where the put together atom, I guess you could say, copper-63, weighs less than all the individual particles up here. So mass defect, to find the mass defect, you subtract the particle one, which is obviously more, by the mass of the put together atom, and this is what you're going to get right here. So now to find nuclear binding energy, and this is when the missing mass is converted directly into energy, and that energy is what holds the bind together. So to solve for this, you use the formula E equals mc squared. And right here is your C, and C is always 3 times 10 to the third meters per second. And then up here is our mass defect, but we need to convert it to kg, kilograms, in order to plug it into our equation. So this is just the conversion that I did. So now this is the final product of my conversion, and I'm plugging both of these into the equation. So you get E equals mc squared, and you need to always make sure to square C. So then you get the 8.849 times 10 to the negative 11th, and it's in kg, meters squared over seconds squared, but that is basically the same thing as joules. So, and you want it to be in joules. So you just do joules as your final, and this is your final thing. So that's mass defect and nuclear binding energy. Thank you for listening and watching.